Hi folks, welcome to the show.
Today, we will talk about what mathematics is all about.
Before we start, let's walk around and ask what mathematics is about.
So today, we are going to ask students here in LaSalle on how would they describe mathematics in one word. Let's go! Hi Miss, excuse, can we ask you a question? How would you describe mathematics in one word?
It's complex.
Painful.
Too much numbers.
Thank you.
So, mathematics is hard, full of numbers and symbols and complicated formulas, complicated patterns, and things that are barely understandable at first glance.
But to some, mathematics is fun. Do you agree with that?
Well,
So, what is mathematics really about?
Mathematics is more than just numbers and arithmetics. Those are just the tip of the iceberg.
Mathematics plays a vital role all throughout our daily lives, like reading and writing. Its absence is a major handicap. A large part of history includes the evolution of counting or use of numbers.
but we should start at the history of mathematics and how numbers and counting was developed. A lot of the early prehistory of mathematics is from different civilizations. People before used their fingers and toes to count until they developed clays and scripts and special symbols. But did you know that the oldest mathematical artifact was found in Africa?
Really?
Yup! The Libombo bone was approximately about 43,000 years old. It was one of the earliest mathematical artifacts. According to the Universal Book of Mathematics, the Libombo bone's 29 notches suggest it may have been used as a lunar phase counter, in which case African women may have been the first mathematicians, because keeping track of menstrual cycles requires a lunar calendar.
Next mathematical discovery was fractions and integers. The earliest fractions were reciprocals and integers, ancient symbols representing 1 part of 2, 1 part of 3, 1 part of 4, and so on. A modern expression of fraction known as binarashi seems to have originated in India in Sanskrit literature. Their works form fractions by placing the numerators, Sanskrit amsa, over the denominators, cheda, but without a bar between them. The integer was written on one line and the fraction in its 2 parts on the next line.
Do you know this number? This wasn't a number before. But in between 400 and 1200 AD, the concept of zero was invented. And speaking of zero, it took a long time until zero was accepted as a denoting number. Like the number 0, the number 1 was also not considered as a number 2.
The next extension of the number concept was the invention of negative numbers. So negative numbers can be thought of representing them. It can be interpreted in many different ways. An example, negative temperatures are one that is colder than freezing. An object with negative velocity is one that is moving backwards. So the same abstract mathematical object may represent more than one aspect of nature.
The ancient Greek used unit fraction and later continued fractions. Followers of the Greek philosopher Pythagoras discovered that the square root of 2 cannot be expressed as a fraction of integers. Around 250 BC, the Greek mathematician Archimedes created an algorithm to approximate pi with arbitrary accuracy. The first computational formula for pi, based on infinite series, was discovered a millennium later. The earliest known use of the Greek letter pi to represent the ratio of a circle's circumference to its diameter was by Welsh mathematician William Jones in 1706.
However, mathematics is not just about numbers. We also have operations like addition, subtraction, multiplication, and division.
My favorite album was Divide because it has Shape of You. I'm in love with the shape of you.
That's not what we're talking about, okay?
Oh, okay. We also have functions or transformation. Operations and functions are very similar concepts. But what are their uses? They are used to verification. Basically, making abstract things come true. This is a mathematician's most powerful weapon. So basically, in the words of Ian Stewart, it is thingified and given value as much as the real thing.
Mathematics is not just a collection of isolated facts. It is more likely a landscape. It has inherent geography that its users and creators employ to navigate through that would otherwise be an impenetrable jungle.
The thread that knits this landscape together is proof. Proof determines the route from one fact to another. To professional mathematicians, no statement is considered valid unless it is proven beyond any possibility of logical error.
It is interesting to know and develop a deeper understanding of mathematics, especially knowing how it was developed over time and how much proofing and theories goes into it.
We are Group 3 and this is the end of